Welcome back, ladies and gentlemen. It's Benedict here again from BJ Learn, and in this class I want us to talk about schemas. So I want us to talk about star schema and Snowflake schema. So we'll start by talking about star schema. So the schemas are used in data warehousing to organize data in a structured format to facilitate querying and reporting. So schemas are just meant for data warehousing, where we organize data in a structured format to facilitate querying and reporting. So we'll start with the star schema. So I'll take you to a PowerPoint where I have the star schema. So the layout here is in form of a star. So when we talk about a star schema, it is in terms of the layouts. Like now you can see we have the fact table at the center, and then the dimension tables all around. So this is the fact table. It's called sales data, and then now we have the dimension tables being connected to it around through the relationships. When we talk about relationships, we mean how we connect data via foreign keys and primary keys. So the customer or the dimension tables will have primary keys, which will be referenced by foreign keys from the fact table. So the layout itself is giving us the structure of a star schema. So the fact table is at the center, and then the dimension tables are being connected to it around it. So let's move to Snowflake schema. So when I talk about Snowflake schema, we have some other dimension tables being connected to dimension tables. Like now we have the sales table at the center, which is a fact table. Then from the fact table we have dimension tables. This is the dimension table connected to the fact table. The customers table is also a dimension table connected to the fact table, customer table as well. And then we also have the products table as well being connected to the fact table. So the other two tables which are not directly connected to the sales table have been connected to their fellow dimension tables. So now we have customers, and then the regions within the customers resides also has a table. So we have customer regions. So the customer regions has been connected to customers table, but they are both dimension tables. So the dimension tables have been broken into smaller pieces and then being connected. The same applies to where we have the products, and then we have product subcategory. So the subcategory table has been connected to the products, but they are both dimension tables. So we are trying to break down the dimension table to smaller pieces, and by breaking down the dimension table to smaller pieces, we are just trying to denormalize, rather we denormalize data we reduce the redundancies within the products table by bringing out the subcategory to its own table. So within the products table, we not have the redundancy because we've created another table to hold the product subcategory. The same applies to customers. Instead of having customers regions within the customers table, so we are breaking down the customer regions from the customers to form another table for customer regions. So the connection here is what we call the Snowflake Schema, where the dimension tables are also being broken down and connected to themselves. So this is all about the Snowflake Schema. But before then, let's try to note the difference between a Snowflake Schema and a star schema. So down here we have the differences in terms of features. So the first here is we are saying that we have a feature for structure, and then we are saying that when it is a star schema, a central fact table connected to a denormalized dimension table. So denormalization is holding all the data fact, or rather all the data within a single table, as opposed to breaking them down into smaller tables. Like now we have the star schema here. So here we are saying that the data has been denormalized, meaning that where we had the customer regions, now instead of having customer regions table, we hold that customer regions in some column within the customers table. So we'll just have a single dimension table. So we are saying the data has been denormalized. And then when it comes to Snowflake schema, central fact table connected to normalized dimension tables, which are further broken down. So when we come to Snowflake schema, you can see the products table have been broken down into a product subcategory. When we come to customers, again, the dimension table has again been broken down further into customer regions. So another feature is about complexity. So we are saying that star schema is simple and easy to understand. So this is self-explanatory. You can easily see that we have a star fact table at the center with dimension tables around it. And then when we go to at Snowflake schema, we are saying that it is complex due to multiple levels of relationships. So the multiple levels of relationships are here. You can see here where we have the customers table, which is a dimension table. It's also again connected to another customers regions table. Moving to products, again we have a products table, and then it's also connected to product subcategory. So we have indirect connection of product subcategory to the sales data through the products table. So again we are having a normalization as a feature. So we are saying here that in star schema we have data denormalized, meaning that redundant data for faster querying. So data is being held in a single table as opposed to being broken down. And then in a Snowflake schema we have normalized data, meaning that data has been rather it reduces redundancies but increases joins. So when we come here to Snowflake schema, you can see here where we have the products. So now we have increased the joins. The joins here is this arrow here, where we can have a single join or a multiple join. But now the joins are being multiple in the sense that after having a dimension table products being connected to sales table, we are also having another join from products to a subcategory, product subcategory. So we are having many joins. That makes it a normalized data, but which reduces redundancies, but the joins are numerous. So another feature here is query performance. So star schema has faster query performance because we have fewer joins. So when I come here to star schema, you can see now we can count the joins being 1, 2, 3, 4. The connections, that is, we have 1, 2, 3, 4 joins. As opposed to when we go to Snowflake Schema, we have now 2 additional joins, which are now 6 joins. So that means that when it comes to query performance, Snowflake Schema is slower, as it requires multiple joins between tables, and this one requires fewer joins. Then when we come to storage space, we have star schema is having or rather it takes more space due to data redundancy. Then this other one takes less space due to data being normalized. There is no redundant data, it has been removed, or rather the redundant data within a given table is being broken down to another table to form another dimension table. And then we also have another feature, ease of maintenance. So when it comes to ease of maintenance, we are saying in a star schema that easier since fewer tables are involved. This is very true. When you come here, you can see we have 5 tables, the fact table and the product tables being around, which are 4. So we have there are 4, so we have 5 tables, as opposed to a Snowflake schema where we have now 2 additional schemas, making them 2 additional tables, making them 7 tables. So that makes the maintenance a bit harder in terms of complex relationships. So this is what we mean here, harder due to complex relationships. And the last feature we have here is a use case. So star schema is suitable for simple and fast querying such as dashboard and reports. And the Snowflake schema is suitable for complex analytical queries where data integrity and space efficiency are priorities. So I want us to do this by having an example practically. So let's go to our Power BI desktop. We see how we can create a star schema and a Snowflake schema. So let me just come here to blank report. Then I want to name it, let me name it schemas. It's a blank report. I want to save as. So I'll save it in PBIX file. Then I'll save it schemas. Then okay. So here I want to import data where we'll create both Snowflake schema and the star schema. So first here, before I import data, I want to make sure that there will be no automatic relationships being created when we import data. So I will go to file, then I go to option and settings. I go to options. Then I'll come down where we have, forget about the global part, but we come down where we have the current file. Then I'll go to a current file, then load data. Then now where we have the relationships, I want to untick these boxes. So I don't want the relationship to be created. We want to take control of creating the relationships. Then we click OK. So now here we load data, and then before we load data, just want to mention that as schemas are concepts of data modeling. So when we talk about schemas, just know that we are still doing data modeling. So I'll go here to where we have get data. First, we must be at home tab, then we click get data. So I want to use Excel workbook as our data source, and then I want to use AdventureWorks 2020, then open. So let us see the preview of the tables that we have. So what I want to bring in, the sales table. I also want to bring in products, and then I will also bring in a calendar table, and then customers. Customers, I will leave customers alone. So I want to use the three tables. So the sales table will be our fact table. You can see what we have as our sales table with the numerous columns. And then we also have calendar. This is a dimension table. So it give a descriptive data or textual data, but this one is now for date. And then we also have products table, which also describe the facts we have within our sales table. So it describes the facts about the products that are being sold within the sales table. Then we can now load the data. So we want to create a star schema first, then we'll go to Snowflake Schema. After loading the data, ladies and gentlemen, now we go to a model view. So we click the icon for model view. Then now we need to create a star schema. So we must have our fact table at the center, and then the other dimension tables being put around it. So first I will bring this table here. So this is our fact table. Then this is our product table. I want to put it here. We try to bring this one up here. So I want to add another table to create to have three dimensional tables. Let me just add another table. So I want to bring in the calendar, rather the customers table. This is another dimension table. Then I will load. So it's been loaded, and also we can see it within our model view. So I'll just bring customers down here. I'm just trying to squeeze it a bit. So we have our sales table and the three dimension tables. So let's first do the connection. So the fact table is at the center and being surrounded with dimension tables. So within the calendar table, I want to connect the primary key and the foreign key. So the primary key will come from the calendar table, and the foreign key will have within our sales table. So our sales table, we have order date. So we want to use the order date. We connect with date within the calendar table. So the date here will be our primary key, and then the order date will be the foreign key. Then within the sales table. So we have a connection of one to many from the date table to order table. Then here now we'll click save, create the connection. Then again we want to connect the products table with the sales table. So we want to see what is the foreign key within our products table. I think we'll use the product key. So we'll use the product key as our primary key for primary column or for primary keys in the products table. Then we connect with the sales table. So the sales table again will have the primary, rather the secondary key or the foreign key, where we must have, or rather we must use also the product key. So I will connect the product key here with the product key column within the sales table. So I will drag this and drop within this sales table. So we have products table being connected with sales table, and then the cardinality is one to many, cross filter is one. So cross filter direction is from the products table to sales table. Then we click save. Then we go to the customers table. So let's see what is the primary key, or the primary column within the customer table, and then it should be customer key. So we need to search for customer key within the sales table. So we have customer key here, we also have customer key here. So we want to connect this primary key with the foreign key within the sales table. Then now we'll click OK, and then you can see our cardinality is one to many. Then cross filter direction being single. Then we click save. So now we've made our star schema. So this is the practical layout of star schema within a Power BI report. The cell fact table is at the center, and then we have our dimension tables being around it. So the same now we want to apply when doing our Snowflake schema. So we said that the Snowflake schema, we have dimension tables being broken down into smaller pieces, and then they are connected to themselves. So like now we have the products table. We can also have another table being broken down from the products table, and then we connect that table to the products table. So that will form our Snowflake schema. But before then, I want to arrange this into a Collie layout methodology, where the fact table is down and the dimension tables being up, but it still remains the star schema. So I'll just push this one down. I will push this one up, and then I will bring this one down. So I'm bringing the table down, and all the dimension tables, I want them at the top. So this is what I'm calling the Collie layout methodology, where all the dimension tables are at the top, and then the fact table being at the bottom. But we are still forming the Snowflake schema, so we need to add another dimension table so that we can connect with other dimension tables. So I will go to Home tab, then Get Data, then Excel Workbook, then AdventureWorks 2020, open. Then now I want to bring in a product category and product subcategory. I will bring these two tables here. Then Instead of bringing the two products, let me bring the product subcategory, the product category and the territory. Then I will load. So you can see we have the territory key within our territory, and then we also have product subcategory. So we load. Then now we have our territory. We have the territory key. We have the group region and all that. So let's see what we have within our product category, product subcategory. We have the product category key and product category alternative key. So we want to connect this product category key with product subcategory. Product category key and product category key. Now we don't have product category key here, but we are assuming that the product category key is the same as the product subcategory. If not, then let's try to bring in the other table that we left. So we'll add another table here, and then I want to bring in a product subcategory, this one here. Then I load. So let me do away with the territory. Territory is just a dimension table on its own. So I will delete this territory table. Delete. So I want to bring in so let me try to push this one this side, so you can see all the dimension tables on top. So these are all dimension tables. Now we want to create the Snowflake schema. So we have the product category key and product category key. So let's search under product list. We have any key that is so here we have product subcategory key, and so this one I want to bring this side. So we want to form a Snowflake schema, then this will come here. So I want to connect the product subcategory key with the product let's see if we have product subcategory somewhere here. Product subcategory is also here. So I will connect the product subcategory key with the product subcategory key within the product. So this is a relationship from product subcategory to products. Then product subcategory, then the relationship is here. Cardinality is one to many. Cross-filter direction is single. Then we save, and then we go to this other product category. So we want to connect the product category key with the product category key within the product subcategory. So we'll connect this primary key column with this for any key column within the product subcategory. Then cardinality is one to many, cross filter direction is one, then we save. So now we've connected the tables, the dimension tables. These two tables have been connected indirectly to product key. So this is what we are calling the Snowflake Schema. So now from here you can do your data. You can go back to report view and do your visualization. So this is what we call the Snowflake Schema. What makes this Snowflake Schema is the breaking down of these two dimension keys from the products table. So that was all about schemas. So when we come next, we'll see what else we'll talk about. So thanks a lot for watching, and let's meet again on the next class.